So in this video, we're going to look at finding extrema on a closed interval. So what that means is they're going to give you a domain and they're going to tell you where my x value starts and ends. And what that changes is that endpoints are always max and mins. Okay, we talked about that in a previous video. And a sign chart will help you determine if you have a max or the min at the endpoint. Okay, so you have to include your max and mins on your sign chart if they give you a domain. Okay, so it will look something like this. Find the maximum minimums of f of x equals this function on -10, 3. So this is my domain, and I'm starting at -10 and I'm ending at 3. So x equals -10 will either be a max or min, and x equals 3 will either be a max or min, and I need to include those. Okay. So we do the first derivatives test anytime we're trying to find max or mins. It's the same process. So we, again, first take the first derivative. So this one is 6x squared plus 6x minus 36, and I'm going to set it equal to 0. Okay, so first thing I look is for a GCF. I can factor out a 6. So I get x squared plus x minus 6 equals 0. And then I'm going to see if I can factor this, and I can. I want to what multiplies to -6 and adds up to -1. Or adds up to a +1. So that would be 3 and -2. That adds up to a +1. So I would have x plus 3 and x minus 2. Okay, and then I'm going to set all my factors with an x. So I have x plus 3 equals 0, x minus 2 equals 0. I don't do anything with the 6 because 0 I could divide by 6, and 0 divided by 6 is just 0. So I get x equals -3 and x equals 2. So those are my two critical values. And then I'm going to make my sign chart. Okay, so I need to include -10 and 3 on my sign chart. Those are my starts. So, and I usually do the number line especially for these. So I have -10 and a +3. And then I have -3 and a 2. Okay, and so here is where my derivative 0, and then I put EP on -10 and 3 for endpoints. And again, endpoints are always max or mins. That's a key thing. Okay. So I have to figure out in each interval if my function is increasing or decreasing, which means I have to figure out if the derivative is positive or negative in each interval. So I pick again my test point. So my intervals again are -10 to -3. That's my first interval. My second interval is -3 to 2. And my third interval is from 2 to 3. Okay, and I need a test point in each of those intervals. So from -10 to -3, I'll just do -5. And we plug it in again to the derivative to figure out if it's a positive or negative. Now, for this one, if you're not going to use your calculator, like I said on the last one, I often use the factored one as long as I'm confident that I factored correctly, because I can quickly figure out if this is positive or negative in my head, and I don't have to calculate it all. So what I mean is I'm going to plug -5 into here. And if you don't want to actually find the value, what I can do is I can just say, okay, I have a negative. -5 plus -3 is going to also give me a negative. It's a -2. And -5 minus 2 is a -7. And so I have a negative times a negative, which is a positive, and a positive times a negative, which is a negative. And so this is negative, and that's all I need. I don't have to find the value. Okay. If you didn't follow what I said or what I did, then you can do what we did in the previous videos is you can just type in your derivative. I'd probably type your non-factored one if you're going to do it this way into y equals. I type that in, go to second table set, and either have it on ask or change it back to all of the values. And then I'm just going to type in -5 and get that it's a positive positive 84 because this should not be a -6. This should be a +6. So this was a +6. A positive times a negative is a negative. And a negative times a negative is a positive. So this should have been positive. So you can, again, either type it into your original function, into the derivative, and use your calculator, or figure it out in your head just based on the signs of it. Okay. So then I'm going to do my other test points. So I need from -3 to 2. Again, I always use 0 if it's in the interval because that's the easiest for me to calculate. And you can, again, either do the factored way or type in 0 here and get it. So it's a -36. But on here, I could easily see, okay, positive times a positive, positive times, that would be a negative, and so it's a negative. Okay, so this is negative, and then I have to do my last test point. So I have to do between 2 and 3. I'm going to do 2.5. Okay, so we're going to find f prime of 2.5. And this one is a positive. These are all positive. Again, if you want to type it in your calculator and just confirm, you get a positive. Okay, so then I can see what is happening for F. So I do my test points, I plug that in, and then I'm going to see what's happening with F. So F is increasing from -10 to -3. It's decreasing from -3 to 2, and increasing from 2 to 3. Okay. So that means at 0, it's going up and then down. So I have a max. At 2, it's going down and then up. So then I have a min. But I also have to test the endpoints. Okay, so the endpoint at -10 is I was started down and then I'm increasing. So I can see from my arrow that this would be the lowest value. And at 10, I have a min. And then at 3, if I look at my arrow, my function is increasing until I get to 3. And so 3 is going to be the highest point and 3 is a max. And I like the arrows because it helps me visualize the endpoints. Do I have a min or do I have a max? Okay. So these are my 4 critical points, my 4 max and mins, and this says find the max and min, so that's what I need to find. So I have x equals -10 as a min, x equals -3 is a max, x equals 2 is a min, and x equals 3 is a max. I have to find the points, and I have to find the y values for each of those points, and then we're going to talk about which one is the absolute or the global max after that. Okay, so I need to find f of -10, f of -3, f of 2, and f of 3. And again, we're not using our test points, we're using our values that we found for our critical points. So make sure that you know which one is which. So I'm going to plug it into the original function f of x to get the y value. Let me write that function here. And then I would, again, just be smart about this time-wise, like it's usually faster, is I would go to y equals again, change my function to this function. So 2x cubed plus 3x squared minus 36x plus 2. Okay, so I'm going to do that. Hit second table, and then I'm going to type in my values. So I have -10, -3, 2, and then 3. So I'm going to find the 4 y values and type, and then write those out. So I get -1,300 38, 83, negative 42, and negative 25. So those are my Y values, and now I need to say min or max. So I have a min at negative 10, negative 1338. And my other min was at 2, so at 2, negative 42. Okay, and then I have a max at negative 383 and 3, negative 25. Okay, so those are my max or mins. Now, the other question it might ask is, what is my absolute max? Okay, or they could say global, or what is my absolute min? And so when they ask about the absolute min or absolute max, I look at my maxes. And for the absolute max, I look which is the higher max value. And I'm looking at the Y value. The Y value tells me where the max is. So 83 and negative 25, 83 is definitely higher. So the absolute max, the point is negative 383. If they say, what is the max? You give the Y value. Okay, so the absolute max is Y equals 83. If they say, where is the max? You give the X value. Say the absolute max occurs at X equals negative 3. Okay, so the absolute min is the lowest Y value. So negative 1338 is definitely lower than negative 42. Okay, so remember, a bigger negative number is lower or smaller. And so I have my absolute min is negative 10, negative 1338. Again, if they say, what is the absolute min? And I'm just writing min, but if they say, what is the absolute min? I would say Y equals negative 1338. And if they say where, I would say at X equals negative 10. Okay, so that is how we find the global max and mins and how we find the max and mins on a closed interval.